Hi, my name is Jeff. I work on Firebase, and in this video, I'll show you how you can use Firebase AI Logic to implement your AI-powered chat features in your apps. My team and I have been working on an app called Friendly Meals, a meal planning web app that suggests recipes based on user preferences. On this first screen here, users can generate a recipe based on a list of ingredients and other requirements they provide. Here's a recipe the app created for a list of things that I found in my kitchen today. While the current version of our meal planner works well, we realized we could improve the user experience by introducing a conversational, AI-powered interface. Imagine this. Instead of just getting meal suggestions, you can chat directly with your personal meal planner, just like you're talking with a friend or a chef. This isn't just about convenience. It's about unlocking dynamic personalization. You won't just receive suggestions anymore. You'll actively shape them in real time. For example, if your meal planner suggests a pasta carbonara recipe, but you don't have all the ingredients, you could ask if you could use bologna instead. The AI would understand your request and adapt the recipe to your preference. This turn-by-turn conversational flow allows for an organic, iterative process. You react to the app's responses, it reacts to yours, resulting in a truly tailored result. Before we can start implementing this conversational meal planner, here's a crucial technical detail we have to cover first. It's foundational to how these things work. Large language models are inherently stateless. They don't remember a single thing you just told them, not a message from 10 seconds ago, let alone 5 minutes ago. So if the AI doesn't recall that you were talking about pasta carbonara a minute ago, then when you say, "Can you use bologna instead?" it has absolutely no context. It'll probably give an answer about a sandwich that's completely unrelated to pasta carbonara. That would be a frustrating conversation, wouldn't it? So now you're probably thinking, but wait, how do all those AI chatbots work then? I can have a conversation with them, and they remember what I've said earlier. The secret is this. To help the model know what has been discussed before, you have to send the entire history of the conversation with every single request. That's right. This means every single thing you've said, and every response the model has given, and then what you've said in return, and so on and so forth. All of this needs to be sent to the model with every single request. It's a bit like giving the AI a complete transcript of your chat so far. Now, you might be thinking, I wish it would just remember. But don't worry, Firebase AI Logic has you covered. It can automatically store the chat history and send it along with every request. Firebase AI Logic offers two primary APIs for interacting with the model, generateContent or sendMessage. The generateContent method allows you to communicate with the model in a stateless manner. Here is a video where I explain how it works in detail and how I used it to implement the first screen of this meal planning app. But as we've just discussed, it doesn't keep any conversational context. Hi, my name is Jeff. I work on Firebase, and in this video, I'll show you how you... Wait, did I say that already? We better figure out how to maintain context before I start over again. Where was I? generateContent, no state. Oh yeah, this is where sendMessage comes in. Unlike the stateless generateContent, sendMessage automatically manages conversation history. It stores both the user's messages and the model responses in a way the model understands. That way, the user can refer to something from earlier in the conversation, and the model will know what they're talking about. To use the chat API, first get an instance of the model you'd like to use. Here, I use Gemini 2.5 Flash, which is a great model for fast performance on everyday tasks. By default, Firebase AI Logic will communicate with the model via the Gemini Developer API. You can also use the Vertex AI Gemini API, which has support for additional features. To learn more about the differences between the two API providers, watch this video or check out the documentation. A chat feature is also a great way to add some personality to your app. Maybe your brand persona is helpful, or maybe your users would appreciate the sassy personality of a celebrity chef. You can use the system instructions to change the personality of your chat with just a few lines of code. Giving models a personality isn't strictly required, but providing system instructions do help to provide guidance for the model. Now that the model is set up, you can start a new chat. Each chat instance keeps its own conversation history in memory. You can also provide an existing chat history. This can be useful for continuing a conversation or for pre-populating the chat with a past conversation that has been saved in the database. With all the preparations done, you can now send the user's messages to the model. The chat instance will maintain the conversation history for you, allowing users to refer back to what was said before. Here is how we integrated the chat API in our meal planning application. This function is part of a React component that maintains a local list of messages as a state variable called history. The history state variable holds a list of all the chat messages we want to display in the UI. This is different from the chat history that sendMessage itself maintains and contains only the information we need to display the messages in the app's user interface. When the user sends a new message, we will first append it to the component's history state, along with a placeholder loading message from the model. This shows the user that the message is being sent. Then, we'll actually send it to the model. We then wait for the model's response. The sendMessage function returns a promise, so we await it. Once we receive the model's response, we will replace the placeholder model message with the real response. Oh, and because things can sometimes go wrong, we've baked in some error handling. If anything unexpected happens, we make sure to display an error message to ensure the user isn't kept in the dark. And this is how you can use the Firebase AI Logic SDK to create an AI-powered conversational user interaction for your app in just a few lines. All right, let's turn up the heat and talk about how users can incorporate visuals in their conversations. For example, they might snap a picture of what's in their fridge, and the model suggests a delicious recipe using only those ingredients. Both the generateContent API and the sendMessage API support multimodal input. That means you can seamlessly send images or other files when you're generating content or chatting with the model. To send an image, pass it as the first parameter to the sendMessage API. Just like text messages, the chat API automatically keeps a reference to these images in its history for as long as the chat object is active. Firebase AI Logic supports PNGs, JPEGs, and WebP images. A quick note, if you send files as inline data, they'll be base64 encoded during transit, which increases the request size. If a request gets too large, you might hit an HTTP 413 error. In this case, you should either ask the user to provide a smaller image or implement a way to resize the image before sending, perhaps using Cloud Functions for Firebase. You might have noticed that sometimes we had to wait a couple of moments for the model's response to show up in the UI. That is because the sendMessage API waits until it receives the complete response from the model. Let's see how we can improve the user experience. Like most other large language models, Gemini supports streaming. That means the model sends content to the client as it generates it. With Firebase AI Logic, you can make use of the streaming capabilities of Gemini. Our client-side SDKs include methods for streaming and non-streaming calls, so you can pick whichever works best for you based on your use case. Here is a code snippet that shows how you can use the streaming version of the chat API. We can get each asynchronous value from the stream using a for await loop. You can then assemble all the chunks you receive and update the UI as you receive them. Let me update the code for the chat UI of our meal planning app. We were already appending a loading message to the state. I'll then send the user's message to the model using the sendMessage stream function and start looping over the chunks that the model will send via the stream. Inside the asynchronous for await loop, I will first read the text of each chunk as it arrives, and then update the message array accordingly so that React updates the UI. Again, in case anything goes wrong, I'll show the error message inside a chat bubble. When I run the app again, the UI will update as the model sends its response. This significantly improves the user experience by allowing the user to start reading as soon as any words are generated by the model, instead of making them wait for the entire message. And there you have it. You now know how to use the chat API in Firebase AI Logic for both streaming and non-streaming calls. The code for this sample app is available on GitHub. The link is in the description of this video. Thanks for watching.